I'm going to talk a little bit about how space technologies are affecting marine and maritime, which is a large part of the UK's economy, and a little bit about the journey from sort of TRL level 0 through to TRL level 9. And I also want to talk a little bit about the Alan Turing Institute. So a number of people have mentioned artificial intelligence, and this is a really good place to get support for your artificial intelligence needs. I do this as Associate Professor from Maritime Engineering Group at the University of Southampton, where my research is into artificial intelligence and then how we apply that into marine. But also I'm the Group Lead for Marine and Maritime at the Data-Centric Engineering Programme in the Alan Turing Institute, and a non-executive director at Thea Limited, who do voyage optimization software and met ocean data. And so I have a bit of an idea of how things work in the real world and not just artificially in academic problems. So the Alan Turing Institute is the UK's National Institute for AI. It started in 2015 and is just getting towards the end of its 5-year programme. So it's supported by EPSRC and a number of other companies from around the UK. It's headquartered at the British Library. So the pictures on the right are sort of pictures from our offices. And so it's a super nice view as you walk in. And I actually work there 2 days a week. And I think I'm incredibly lucky to be able to do that. The idea behind it is it's a research institute. So there's obviously some elements of developing world-class research, but there's much more of a focus on how we apply that into industry and get impact from it. We're also looking at how you train the next generation of AI and data scientists for different sectors, and also looking at how we can advise policymakers and the public. And really we do this because we believe data science and artificial intelligence will change the world. Within the Alan Turing Institute, there are 8 different programs focused on different areas of research. There's one on artificial intelligence itself, so sort of fundamental artificial intelligence, defense and security. The one that may apply to a lot of people here will be the data-centric engineering program, or potentially the data science for science programs. Data-centric engineering is a really large program. It's completely cross-sectoral and has maybe about 260 engineers now, with a portfolio of about 60 to 80 million pounds worth of research going on. So just a huge body of people who are interested in artificial intelligence. And the great thing about the Turing Institute is this ability to share across sectors. So we can see from the marine industry what's happening in aerospace or food technologies and bring that technology into us, but also share our technologies with other industries. So I want to talk a little bit about an algorithm that I've developed and the potential impact there, just to sort of demonstrate this sort of journey and how you do it. So we originally were funded by Lloyd's Register Foundation to do some TRL Naught research as part of a university technology centre. And what we were interested in is basically how the behaviour of ants in evolution can be mapped into our evolutionary algorithms. So evolutionary algorithms have been used for a long period of time. NASA used them in the 90s to design antennas for spacecraft that went up in the early thousands. But these algorithms are really based on a sort of Darwinian Mendelian view of evolution, and they don't utilize any of our sort of modern research into that area. So we took some of these mechanisms and applied that to the algorithm. And what this did is it improved the diversity of the search, meaning that we gave the top performance on over 100 plus evolutionary computation problems. So in our sort of benchmarking scientifically, it performed very well. But also we've been able to apply this to a number of applications. So I stuck a few in here that might be of interest. One is composite weaves that have very high strength to stiffness. So really good for sort of flexible bodies. So it could be used for flexible antenna. And we gave a 1,050% theoretical improvement over a weave that exists in the real world. So really interested to test that. We've done this on spacecraft structures and sort of shown how we can optimize the bodies of launch vehicles to reduce the mass. And we've also done this to design prosthetic legs that have reduced pressure in certain areas of the leg, so that we can avoid areas that might be uncomfortable for users and sort of improve that. So there's a sort of wide range for these algorithms. So one of the sort of major ways we've used this is through the Sprint program, which was discussed earlier, which I think is a really nice program, a really good way to sort of upscale theoretical research. And what we wanted to try and do is utilize high fidelity weather data that's available from satellites to try and improve voyage optimization. So shipping is really efficient, but it still contributes about 2 to 3% of the world's emissions, and we need to reduce that immediately. So by more accurately routing the ships, we can basically take advantage of things like currents, avoid bad weather, and go at the correct speed to arrive at a closer time to when we want. And that allows us to reduce fuel. So through the Sprint program, we sort of developed this voyage optimization software using the algorithm. And what we've been able to show is a 5% reduction in fuel over competitor algorithms, a 10% reduction in time of arrival at the same time as that, which results in a 7% increase in time charter equivalents. So the ships that we're hoping will be starting to utilize this software later on this year or early next year are using less emissions and saving a lot of money, but also arriving faster as well. And so you can sort of see how maybe perhaps a few different pieces of funding from Lloyd's Register Foundation starting this research, to some PhDs in the middle, to a Sprint program taking advantage of those newly developed algorithms, through to a company now financing that to put it into practice, sort of pieces together these stories and how basically academics hopefully can contribute to some real world elements.